Hello and welcome to Module 3 in Data Science Languages. Today we'll be going over data files and how you manipulate them in both Python and R. So jumping straight in. Our agenda, we'll start off with talking about the reading that you're expected to do, then talk a little bit about the various ways that you can read files in both Python and R, including going through the examples of text, binary, and XML, which is kind of just a special case of text. And then we'll do a few kind of foundational concepts that may be necessary, and then we'll close with a discussion of deliverable 3. So data files. Basically the idea here is to be able to read and write text, XML, binary in both languages, and then the deliverable is the application of that concept so that you'll be loading some files, doing some stuff to them, and writing them out. This is a fairly common pattern that we do in this field. It's around for quite some time. Way back when, that was what we used to do in file processing, is open up a file, do some stuff, close the file. The reading in the Python book is chapter 6, and in the R book, chapter 12. So moving on to Python. There's lots of different Python functions for reading various types of files, and this is just native to Python without getting out into things like pandas. They start typically with the word read, followed by an underscore, and then the type of file that you're reading. A CSV, you should note, it's not just CSV, it's something that is delimited in a textual fashion similar to a comma-separated value file. Example of that is a tab-separated file, right? Sometimes we use different delimiters than commas to separate the columns, and that's the basic idea, is that it's a line of text with something in between it telling you where the various columns start and stop. There's also, way back when, a fixed width file. We don't see those quite as often as we once did, but the idea is that a certain column contains certain values. They're still around. I still see them occasionally, but they're less common than they once were. Sometimes you'll need to be able to get things off the clipboard, out of Excel, and various other files. So they are common. You'll notice, though, in this list of native things is CSV or XML isn't necessarily showing up, so that's kind of interesting. Moving on to file basics. So the basic idea of a file interaction will follow this basic approach. You'll see this a fair amount. We generally speaking will open up a file, then we'll call some method on the file handle we receive back. That's what that as XML file is a handle, essentially, that lets you be able to interact with the contents of that file in kind of an abstract way. So the way files actually work is there's the contents of the file, which is what we typically care about. The file itself is essentially an operating system level construct. And so in order to interact with a file, you have to basically open it. That's literally what it's called. And then when you're done with it, you should close it. Failure to do that could cause bad things to happen, especially in long-running processes. Probably not as much of an issue in something like this, where you're potentially leaving, although could be interesting things could happen inside of a Jupyter Notebook with long-running kernels. So what happens if you don't close that file is that you've locked it. And that means that somebody else might not be able to interact with it. So you want to be very conscious of that. It's a best practice to always close the file when you're done interacting with it, reading it or writing it or whatever it might be. So this basic code is not doing anything overly exciting. It's using a library, XML, to dict, which is short for dictionary. And basically we're giving it, we're opening up a file with the name full in Node.xml. And saving that content into a dictionary, and then we're basically turning that dictionary into JSON and printing it out on the screen. So you get something like this at the bottom of the thing. So it takes it from an XML format to a JSON format. But you'll notice here also line 8, I'm explicitly calling close. That really isn't doing anything, because at the point that we exited this with block, it automatically closed the file. That's why you want to use with every time you're interacting with a file handle, so that you don't have to remember to do it, because you might forget. Also, if something bad were to happen inside of that block of code, for example, an exception, at the point that you exit that scope, that's what we're talking about, the scoping of variables and such. At the point you exit the scope, the file is automatically closed. It's a very important thing to do, and you always want to be doing that. And it is something that if you don't do, you wish you had. So XML, so what is it? You're asked to read it and potentially write it. So what does that mean? So XML is nothing more than a textual representation of data. It uses the concept of a tag. A tag is something that, generally speaking, starts and ends with a less than and a greater than, and then the tag name is what's between those two things, although sometimes there is a shorthand version of a tag where you may just have a less than followed by a slash and a greater than, and what's between it is the tag name and potentially some attributes. But this is a single tag without having an opening and a closing, so it's atomic in nature, so to speak. The tags are generally nested, not just can be, but most of the time they are. That means that a tag contains essentially another tag and so on. And that's where you'll see the right hand over here, this little representation is kind of how you think of what this string is that you see here. So we open a tag A, we open tag B, we then close tag B. Then we open tag C, nest inside of it tag D, and then we close tag C. This is a self-contained one, as is, or this one is self-contained. This is smart enough to figure out that there's nothing between the two opening and closing tags of B, so it essentially converts it to the equivalent shorthand of the same as tag D. So that's a visual representation. We always think of them as hierarchical in nature, so it's essentially a tree. And in fact, an XML document is a tree. It must be a tree. It has a single root node. That root node is called the document node. Underneath of that root node is a series of elements, and there will be one element off of the document node. Everything beneath that, it follows the nature of you have a parent that's required, one parent, and you can have multiple children. So very much a tree. So that's the important things to kind of understand XML in a nutshell. The thing about XML is it can be difficult to deal with, and that's probably part of why it's less popular than it once was. It is definitely a tree structure, and it means it's not tabular. So generally speaking, in data science, we deal with stuff that is often tabular in nature. It's rows and columns, right? But you can sometimes convert XML to rows and columns, but you kind of have to know how to do it, like meaning you need to know the data and the nature of the data and the structure of the data. You can't just blindly do it. You've got to do it in an informed way, and it may be different literally for every set of documents that you deal with. One of the things that you'll often use is a document object model. There are lots of approaches to processing XML. We probably could actually take an entire course and talk about just XML file processing. It would be a rather painful one in a lot of ways, but you could do it because there's lots of different ways of handling XML documents. The next concept is how do you read XML files, and we'll start off with something pretty simple. So first, this is, maybe it's simple if you understand what XPath is, right? And if you have to learn XPath, it may be a little more complex, but basically the idea of XPath is to be able to represent the desire to extract information from certain locations using essentially a domain programming language of sorts. It's a very simple sort of language to where you can, by combining together XPath expressions, extract information from an XML document. And so there's a set of rules to where you can basically say you can look for things that have particular attributes. You can look for a given tag in a given location. You can have wildcards so that you can basically say I want back all of the tags that match the expression, some tag followed with underneath of them egg. So if there's something underneath of that node that has an element named egg, then it will match the pattern and you'll get it back. The dot refers to the current node, and you use it typically to do something potentially relative to where you're at. So you may want to go ... is your parent. So you may want to look for a sibling of a node. You do ... and then potentially a slash and then the tag that you're looking for. The // is essentially a recursive kind of wildcard. Anything underneath of the current node that is an egg will be found and returned into a set of nodes that you interact with. So there's it's a relatively complex sort of things to figure out, but really once you get into it, it's a whole lot easier than some of the alternatives. So what I thought I would do here is start off with kind of a simple example of using an XML document that I extracted from a program called EndNote. EndNote is a resource tracking tool. You use it oftentimes whenever you're doing your research to keep track of articles of interest. It'll allow you to do citations inside of things like Word in a easy to use way. And more importantly, you can attach the PDFs or whatever type of document within it. And so it becomes essentially a reference tracking and a resource tracking tool. So kind of a library of sorts for your personal research. But you can also take it and essentially extract or access the information it stores as XML, because it does use XML. And this is an example of what that looks like. You have a little special thing at the beginning that basically you can kind of ignore for our conversation, but it lets you know things like what version of XML and what's the encoding inside of this file. The root node of this tree is XML. Underneath of it, there is a node called records, and then there's a collection of repeating records underneath of that, singular record repeating underneath of it. And then underneath of them is a series of others. It's important to understand it is a variant record, right? Depending upon the type of source it is, not all the fields will be present. So if you're talking about a journal article versus a book, you'll get different stuff. And that's one of the things that makes it more challenging potentially with dealing with XML, because it is text, right? There's no formal enforced necessarily schema. XML does support the concepts of schema, but generally we don't use them too much. But you can use them, and even then a person could still essentially have something that's valid and that's not valid based upon the schema. But you can notice that sometimes you may have multiple authors. Sometimes you may not even have an author, or it may say that it's anonymous. So there sometimes are secondary titles, but there's not always secondary titles. Sometimes there'll be a periodical, sometimes it's not a periodical. If it's not a periodical, it may not have a volume. So it is the point of all this is that it is variant. So you have to have something that approaches that, or solves that approach in a powerful way. So with this, we'll go ahead and talk through this, and then I'll start showing you stuff, right? So the basic idea of this approach is that we load it into an element tree, and that's what we've imported here. So an element tree, and then we basically tell the element tree to parse a file name that we're giving it. It'll look a little bit different here in a moment, but that's the basic idea. And then I define a couple functions, and what I generally do is I write stuff kind of the slow way first. And then after I find myself starting to write it again, I pull it out and turn it into a function. That's just based upon my years of experience. You may do things differently. You may write them from the beginning as functions. But the functions allow you to basically call it in a way that makes it a bit cleaner. So in this case, whenever I call this get XPath text down here, I'm invoking this function that's intended to return the text element of an XML element. So there's two kind of ways that you can get data out of XML. This is the text element of this particular node. This author's name is in between two tags, and so it's text that is associated with that element. There's also concepts of attributes, and sometimes you want to pull out the value of an attribute. So if for some reason I cared about the style, so better example might be up here. So the reference type is a journal article, and that's an attribute on the reference type tag. The text of that happens to be 17, so 17 is like a lookup value, and the actual what it means is it's a journal article, right? So that's what those are, and these two functions pull from the text or from the attribute. So literally all I'm doing with this code is going through, I open up that XML document, I get the root, and then I go down till I find records, because the first thing should be XML. That's going to be the root. Underneath of root, there should be a tag called records. Underneath of it should be a collection, an array of them called record. And so what I do is that for each record, underneath of records, I go and extract some either text or attributes, depending upon which type of value it is that I'm going for. The stuff in this quote here is what I told you about earlier of an XPath expression. Maybe a little convoluted to look at, but I think if you think about what it's saying from the current node, underneath of it I expect there to be another node called titles, underneath of that a title, and underneath of that a style, and when you find that, return back to me that text. And then I also say this other parameter over here saying, is it required or not, right? So from the current record, is it required or not? And then if it's not required, it's okay to return back essentially nothing, right? If it is required, then that means I want to print out what happened, that was required, and then basically do an assertion of saying that it is required, and I'm asserting that there's at least one thing here. So that's kind of the gist of this, and at the end of all that, I've extracted the values for title, publisher, year, reference type, reference code, and record number, and then I basically am just creating a row or a dictionary, and then an empty dictionary, and so I'm setting the values, so name value pairs onto that dictionary, that associative array, and then I'm adding it to a list of dictionaries. So it's a list of dictionaries. Inside of each dictionary is a set of name value pairs. So that's basically one way of reading an XML and doing something with it. This is the basic running of it. I'll go show it live here in a second, but we can go through and see that it does indeed work. So always a good thing. So let's hop over as soon as I can find the right window and take a look. We are in Python. And pretty sure it's this one. Yes, should be. Let's see if this works. All right. So this first bit up here, don't get too worried about, right? Because basically what I'm doing over here is I have a laptop, I have a desktop. I sometimes access things underneath of Linux. Sometimes I access them from Windows. So I run Jupyter notebooks inside of the Windows subsystem for Linux, and I can show you that terminal right here. And so basically this is, we're looking at this is a terminal onto a locally running instance of Linux inside of the Windows subsystem for Linux on my PC. It's not a virtual machine per se, although it is, but I don't have to run anything special to install it. I just turn on the Windows subsystem for Linux, pick from the Microsoft Store the flavor of Linux that I want, in this case Ubuntu 20, and then pretty much at that point it is Linux, just like every other Linux. The nice thing with it is that it has a lot of interaction between the Windows version of my drive. So this the C drive of my computer is mounted underneath of the mount point C, and then so I can basically cross the boundaries between Linux and Windows in a seamless fashion. So it's pretty cool, and you can even do things like edit a file using a Windows application that is residing inside of the Linux environment. So cool stuff. Anyway, the whole point of that is it allows me to run this code, figures out which computer I'm on and which operating system I'm running. And so if I'm running underneath of Linux, then my directory exists that doesn't exist, that is one name that I use on one computer versus another name on another computer, then it maps it out. So it basically, end of it all is it figures out where the data is that I'm interested in accessing. So at that point we can open it up. I use this ospath.join. I do that rather than the paste methods that you may see, because or just simple plus concatenation, because it takes care of the business of, do I need to add this trailing slash or not? And that can be a pain if you forget to put it. Also, you'll notice I'm using the Linux slashes here, not the DOS slashes or the Windows slashes, primarily because Windows doesn't care and Linux sometimes does. So I go to the one that works all the time. So the next step, I'll go ahead and let's clear all output and then run it again, so we can see it all go through. At this point, I've combined it together, so I know, and if we want to see it, what the path is, right? So we can print it out. And this is the nice thing of this sort of programming approach, is that you can explore and see what things are as you're writing the code. So this is where we essentially create an instance of elementary and then call et.parse. I also go ahead and do an import on pandas because we're going to need it whenever we create that dictionary of our list of dictionaries, most likely. I say that and I'll not use it, but oh yeah, it's down here. So we actually convert or create a pandas dictionary, a data frame from a dictionary. There's probably an easier way to do that, but that kind of shows you how it goes. So we can start off by getting the root. It is element XML, so we know that is the root of our tree. I define those two functions I told you about, one that goes through and basically gets the text out of a node, the other one gets the attribute from a given node based upon some path that I pass in. And so then it's just as simple as, okay, we assign the root to a variable called root, we iterate through it, and then at the items underneath of it asserting that the tag name is going to be records. If it's not true, then it'll generate an exception because it's assuming that that's going to be the case. And then we do the same thing underneath of records. We expect there to be a collection of record. We iterate through those, asserting that, again, that they are a record. And that's primarily because if your code expects things to be laid out a certain way, then you want to make sure you communicate that expectation to the person that happens to be looking at your code, right? So if I come along later and pick this up and start looking at it and trying to apply it to something else, this will tell me, hey, the code you're trying to use wasn't meant to solve this problem. And that can save you a huge amount of time versus just not capturing explicitly what your expectations are as the developer of the code. So let's go ahead and run that. And you can see it's pretty quick, and this is a reasonably large document, right? So went through, I took a look at the first 5, just simply doing the row list because we're doing the colon sort of thing. And then I go ahead and install, if it's not already installed, the tool that will turn that, looks like it actually did install at that time. So the library that converts XML to a dictionary, right? And to see how it works, we can basically give it a string. So this is an XML string, the one we used before, and I say parse it and turn it into JSON, basically. There are times that JSON is easier to deal with, and in fact JSON has pretty much replaced XML in many ways, and part of the reason it has is it is generally speaking a tighter representation. It takes less characters to capture the same amount of information. So if I go ahead here and print below that the same thing, you can see, well, in this case it turned out to not be the case, that XML was actually closer because of the spaces that are in here that don't really have to be there. But if you do something similar up here, then it ends up, you could probably get it towards basically the same, because I think the spaces are the main thing. But especially over the size of a document, because JSON doesn't require a closing tag, and part of that too is it's telling us that there's nothing in there. That's probably really what's taking the space up. The JSON will typically be a tighter format, and it's pretty well taken over as far as data formats go of textual information. So basically what we can do here is basically parse in the XML into a simple dictionary of dictionaries, and then dump it as a JSON, which is what we did, and then you can potentially pretty print it as well, so that it shows it as a little better format. So that's one way that you can do it. There's lots of variety of how you can do it. You don't necessarily have to do it at that level. And in fact, we'll go ahead and take a look at the examples from the online course room. I took the Python code out there that was out there and did some munging to it to get it to where it looks a little better. I haven't completed this process, but it's coming along. Excuse me. So what this does, same thing that it did before, figures out where the data directory is for module 3 because we care. This is just text coming pretty much straight out of it. So it tells us what we're going to do, excuse me, to the file itself. So the basic idea here is we open up the file, we read it line by line, so each line of the file is read in separately. The words in each line will be converted to lowercase, punctuation and numbers will be removed. The words the, is, of, and will be removed, and then the line will be written out to a new file. This is actually something you do, believe it or not. Whenever you're dealing with some forms of text processing and natural language processing, especially when you're dealing with like speech recognition, you sometimes need to do some cleansing of the data to remove things like stop words. That's what these are called. These are words that don't necessarily add much value to the information from a textual perspective. So oftentimes we'll do that. Sometimes you want to get rid of punctuation or replace them with spaces so that you preserve the spacing, and then do some calculations off of it after you do that. So anyway, the point of all that is it's not totally contrived. You actually do this sometimes. And in fact, I did it not very long ago. So here we're going through and basically, I'm being a little lazy here. I didn't use the combine or the path combine with the path combination of strings as I did normally, but I get away with it because I have that trailing slash, right? So we're combining together the path plus the file name. Style thing, I personally prefer to have another variable in there, and I don't typically do all uppercase, but I call it full input file name. That's what I would normally do, and do this instead. It's a style thing. Cap all uppercase, you don't see that much in Python. You see it in some of the other languages, but we don't typically do it that much here. And I also sometimes like to do stuff like this so I can see what I'm actually assigning. So you can actually see the full name of the file, see that it is well formed, and then open it up using that same variable. I would typically do the same thing for the output file name as well. That's a style thing. It's up to you. But those are the things you start looking for whenever you're trying to improve your writing of code over time. So the way this works, we're using a while loop. And a while loop, you kind of have to prime. You have to prime the pump, as we used to say. And not that most people know what that means, but in some pumps, old hand pumps, crank pumps, you had to pour water in the top to get the seal wet so that it would hold, and because they dried out, especially out in really arid environments. So sometimes people would take like a mason jar or a jug of water and leave it by the pump. You don't ever drink that water. That water is to prime the pump. It's to pour it into the top of the pump so you can then pump, right? So anyway, I digress. Once you've read that first line, then the while will basically, the logic essentially is while the thing that is on the other side of that while is something other than null or nothing, loop, right? So you'll enter the scope beneath it, and then the first thing you normally do is, and that's a logical mistake in the program. This goes down here. So it's a minor change, but the reason that matters is if you don't do that, you get rid of that first line, because you read it up here to enter the loop. And you could, if you want to make yourself see what's going on, do a little print here. And to prove my point, we would have gotten rid of, we'd lose that first line. So we read the first line, we enter the loop, we do our logic, and then the last thing you do in that loop is read the line again. That's so that you can get to the end of the file. And you want to do it at the very end of that loop. Otherwise, you'll miss a line. In that case, it's probably the very first line. So here we can see the text that is inside of that file. So I'm printing it out as I read it in. So to prove my point, I'll put it back where it was, right? I'll put it right here. And you'll see we lose the preamble. Did I break something? All right, hold on. All right, where did, oh, okay. So yeah. Um, another thing. So the reason that's doing what it's doing is this whole thing should be inside of a with clause like we talked about earlier. So I'll do this again. I open up the files up here, run it again, and if this were down here, which is what we're going to be considering, you'll notice that we no longer have a preamble, right? So the preamble is all right. So I moved the wrong thing. So this goes up here, or maybe I misread it the first time. Anyway, without getting into too much detail, it looks. Oh, I thought it was a read line. It was line to lower is what we were doing. So all that's doing is converting it to lowercase. So we read the first line, we do our logic, we read the next line here and repeat. The first thing this is doing is taking it, converting it to lowercase with the lower, and then we're essentially joining together everything in here that is not a digit. And then we're doing the same thing again, everything that is not a punctuation. And so the end of this, we'll print it before we start. And then we'll print it before we read the next line, and open and close them again. And you can see that what it did here is it removed the punctuation, also took everything to lowercase, and a little weird on the output there because of the that's probably wrapping on us. Okay, no, okay, these are okay, it's a long line. So basically here we're taking it, we're removing all this, we're taking it to lowercase, merging them all back together. This is kind of a nice way of doing this. So it's basically doing the iteration across the characters. So this is a for C in, or for C in line if C is not in string. And so this is basically an immediate if is what we're dealing with. It checks for, you get the first thing if the second thing is not true, right? So if for some reason it is a punctuation, C is excluded and it's not joined back together across this essentially empty string. It's kind of a clever way of doing it. Fairly advanced way of writing the code. But obviously works pretty nicely. And then down here we're doing something similar. We're going through all of the words and we're saying if the words are not in this list of words, then we add the word in. Probably some other ways to do that. I'm not sure which is the more performant, but that's certainly a way. And then once we're done with all that, we join things together with spaces. And then we can write the word out to the file. And that's literally what we're doing here with file processing. So I'll go ahead and comment out the prints, and sorry for the confusion a little earlier when I misread what was on the screen. And then move on to XML. And we'll want to make sure we execute that as well to close those files. Generally, I prefer to see that inside of a with block, right? But we're not gonna rewrite all that right now, and the reason being so you don't have to worry about opening and closing each time. So another way of doing it to make it to where it would be a little better from a demo perspective is put that there and put this at the very end of that so that we can run that cell over and over again without it being a problem, right? So and to show that it truly is working, I'll go ahead and go to that folder. Let's see here. Look at me navigating there so you don't see something that you may not need to see. And we are in data module 3. Okay, so here we are. And the file that we just did was out py text, right? So if I sort it by date of modification, you can see it's at the very top, and you can see it's all lowercase and no punctuation. So pretty cool. So doing the next bit on XML, similar concept. We open up the file, two files, an input and an output. We're going to use the element tree, do a parse on the file, get the root, and then for each of the child in the root, we're essentially initializing them to some unknown value. So we're saying it's all question marks or 3 question marks. Then we go through and say the name is equal to get the name on this file. And to see what that looks like, so we're talking about input xml.text. All right. So this is the file we're dealing with, right? So we start off with the name and child.getName. So this we're looking through here of the root is data. So customer is what that's going to be, and we're looking for the attribute. Clark Kent is what will come back. So the name is what we'll get. Then we for the email is basically we're looking for things, a child that has the name email underneath of it, and then we're getting the text off of that if we find it. And that's basically what that's doing. Kind of an interesting way to do it. I see why it's being done that way, but it is a little, because you're doing a for loop when you're expecting a single item, right? But it's because you get back a collection from the find all, but you should only find one thing. Probably be a good idea to have a test in there to assert that the length was 1, right? Otherwise you're getting the last one. So if there's more than one email, you'll get the last one is the value. So go ahead and run that, and we can see that the name was Clark Kent, and we were able to extract the phone numbers for those that have them. And this is, again, XML is potentially a very variant sort of thing. So an address may only have a city, an email, maybe the only things you have for somebody, and so on. So this is kind of a common problem inside of XML, is that it is very much a variant record sort of thing. And it's done that way purposefully to reduce the size of the files. So you don't have every possible tag having an empty value. You only have those tags present for the values that you have. And so to take a look at again, look at the most recent, we don't actually, yeah, we do write an out XML. Oh, this didn't write it out, but this one does. So again, similar sort of concept, and what we're doing through here is we took this data frame we created up here, and we're turning around and writing it back out as an XML file as well. So the output, not terribly pretty because it's got that .text extension on it, but if we take that off and open it up in a browser, it should be a lot prettier to see. So give it a moment. And of course it's not in that one. Okay, 2 for 2. How about where's Notepad++? Give me one moment. And will it not format it for me? All right. Well, it did write it back out as in the same sort of format. And probably the difference here, though, is see if I got something that'll actually show it cleanly. Is that it should have values for everything. So in this case, notice that the street is set to question marks because it's a street and city we're missing for that particular record. So that's an example of taking data and essentially cleansing it, which is, again, something we do a fair amount of. Binary. This one doesn't really do much to it. It doesn't seem to do anything really. It's just we're opening up one binary image and writing out another one, just giving it the name, doing so a byte at a time. So we're opening up the file, we're reading it. While there's a byte to do, we read it, put it into a list of bytes, then close it, and then at the end we take that list of bytes and write it back out to another file. Generally speaking, if you go to the trouble of opening and closing a file, you do something with it, but it gets kind of complicated when you're dealing with images, and you can see here that it's the same image. It would have been probably more interesting to do some manipulation of the image, but JPEGs are, it's not as simple as an array of bytes, and a byte corresponds to a pixel. It's got some compression going on in there and stuff, so it's a little more tricky than just doing something to it. But that being said, that is something we do a fair amount as well. Generally though, you do something with it. So you may open up a binary audio file and do something with some libraries to maybe resample it to a different bit rate, or you may manipulate it by removing silence or something. So we generally do something. And sometimes with images, when you're doing image processing, you take a relatively large image and you essentially downscale it. Counterintuitively, too much information can oftentimes result in poor performance. So anyway, moving on, here's XML files to JSON. We kind of already went through that. It's basically a way of converting XML into JSON documents. Another example, again, try except is not a good way of handling flow control. So this was an example that I tried of basically early on of, well, I'll just ask for it, and if it's not there, then it's a blank, you know, and handle the exception with a try and except. This is really bad. Don't do it, in part because it can take a really long time to run. And that's because we're using try except for flow control. Never a good idea. A better approach is to do something where you check to see if a value is present before you try to use it. And that's what this function is doing. So that's pretty much XML. And so now we'll go through, in Python, now we'll jump into R and go through it as well. This is something you might need to know if you're going to use one approach with inside of R, is this concept of apply. And what apply does is it essentially does kind of what the name says. It applies something to each element inside of either a vector or a matrix or a data frame. So basically what that means is you can take say a matrix, and you want to apply a common function to each one of it, so maybe something like sum. You can take it and say apply this to every row in the matrix, and so it's a way of doing something related to very similar to, and probably the inspiration for, lambda functions in Python. And there's also the concept of various variations. lapply is used on lists, sapply, vectors, lists, and data frames, and it returns a vector or a matrix, and tapply that's used when you're using a factor. The reason we talk about that is that there's also a variant of that which will work with XML. So here, and that's where this XPath sapply is, right? And so what that's basically doing is applying essentially, or we're using sapply to apply an XPath function onto essentially a record inside of it. So it's a way of doing something similar to basically go through, apply this function, XPath function, to the records inside of the record, and to pull out this XPath function and get back the results. So we get back essentially all the authors, all the record numbers, all the publishers, and so on, and then you can just print it all out. So it's a way of doing it in a high performance way. So we'll jump in and talk about that quickly as soon as I find it. So yeah, this is it. So basically the same sort of code before, and making sure that XML is installed, and it apparently is not. Then we basically can say we want to use that library XML that we're just installing up here. And then the basic idea is to parse these files, this file, the EndNote XML file, and hopefully this will work, even though there's 2 slashes in there because I had one here and apparently it stuck one in for me. I'm not too sure why I did that, because it shouldn't have, unless it didn't know that that's a slash. Anyway, so we go through, we instantiate that library, use that library, create it. Basically, we do a parse, so we get back the results of that function. We take it, and we can then get the node set that corresponds to records. So this is similar to an XPath query, and that actually is an XPath query of saying, give me back everything inside of this document, all of the record elements, regardless of where they are. So // is give me everything that matches that expression. It finds that node, so anywhere in the tree, so all record. And then we can take that records collection and essentially use sapply to apply this function, XPath function, to it, passing in as a parameter the expression that we care about, which in this case is author, or dots whack whack author, and then you get back from that a value that it returns, or potentially nothing, right, depending upon what it is. So and that's basically it in a nutshell. So moving over to briefly go over the R code from the course room. Similar sort of concept as what we did on the Python. You basically can read in some text, let me get the right one. Yeah, here we go. Same sort of concept. Read in some text, dealing with the same sort of thing as far as punctuation, getting rid of the line numbers, and then stringing it back together. Remove the noise words, and that's what this is doing. Is saying construct a list such that the list contains, that is, doesn't contain things that are in this essentially vector of words, and then essentially return that back, and then write it out to a file, copying together with spaces. So we're taking those lists and combining them together into one big thing, and then writing it out, and then closing the files. So very similar sort of flow, same sort of thing with XML. Using a similar sort of approach as some of the others. It's basically, although here we're saying convert this XML to a data frame and then use the data frame. Kind of one way to do it, some ways simpler, and you're very much, though, essentially converting it into a dictionary and then accessing that dictionary for each record inside of that dictionary. So that's basically what we're doing here. Similar concept of if it contains a value, then in this case it's unknown or no email address, so we write them out in a little smarter way than just the question marks. So that's basically it. So with that, I'll switch back and talk briefly, very briefly, about the deliverable 3. Basically, what we've just talked about is pretty much what you're supposed to do. You're going to be reading and writing files in those 3 formats. Your deliverable instructions, 2 distinct submissions. The first one is to read, write text, binary, and XML in Python, and then the same thing in R. XML should be roughly, or at least 1K in size. That should be really easy to find. You probably could even write one that's 1K. And You need to demonstrate parsing or retrieving, printing out specific attributes of interest. So you're not going to just dump it out, but you need to pull various things, either attributes, text, or whatever from the things in general. So you're manipulating it in some fashion. And then make sure that you include both your source code, because that is essential. I need your source code. That means your .r or your .py file. And you can put the .text extension on there. It makes my life a little bit easier if you do so, along with your input and output files that you used, and so on. So the rubric, shoot for the mastery column as always. Make sure that it's at least 1K. The code has significantly more error checking to ensure that data was read into R. That's going to be things like not just error checking, but best practices as well. So make sure you have probably with blocks, or at very least you make sure you close your files. Make sure that you handle the exception caches and so on. The same sort of, and make sure that the stuff that's written out seems to be appropriate. Make sure values are present and so on. The same sort of thing with doing some data type conversions, such as integers and strings, and make sure that they includes more than one type of data, such as integers and strings, and also you have some missing data. So make sure there's some data that's not present. Make sure that there is some text and numbers, and then write the data sets using R for the various file types, and then repeat for Python. And with that, if you have any questions, let me know. That's what I'm here for. Stay safe, and we'll speak again soon.